Hello. In this video, we're going to go ahead and start looking at the quadratic formula. Now, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And yes, I am going to make you sing the quadratic formula in class, so get ready. Anyway, I want to go ahead and prove the quadratic formula because a lot of people don't actually know where this comes from. The quadratic formula comes from solving the general form of the quadratic equation. And if you remember, the quadratic equation is ax squared plus bx plus c is equal to 0. Now, here's the thing. There is one caveat, or there are, I guess, a couple of caveats. First, we have a must be not equal to 0. And specifically, it should be greater than 1 as well. So think of a needing to be positive. Excellent. Now that we have that, I'm going to go ahead and write down ax squared plus bx plus c equal to 0 here. And what I'm going to do is I'm going to use completing the square to start here and solve this equation. So the first thing I want to do to solve is to put it in the form of x squared plus bx equals c. Now the b and c here that you'll see aren't the same that we'll have here. But we want it generally in this form, which means first of all, get this constant term to the right-hand side, which means we have ax squared plus bx equals negative c. Then we want a 1 in front of x squared, which means we want to divide everything in here by a. So divide by a, divide by a, divide by a. And again, because a is greater than 0, that means a cannot equal 0, which means we're not dividing by 0, so this is a valid operation. From this we get x squared plus b over ax equals negative c over a. Awesome. We are now in this form. Now notice that the b in this case is actually b over a, and the c in this case is negative c over a. So I take the number in front of x, which in this case is this positive b over a, and I divide by 2. But remember, I said that if you have a fraction, it's the same thing as multiplying by a half, and that's what I'm going to do here. So b over a times a half, b times 1 is b, 2 times a is 2a. We're going to take this, and now we're going to square it. And if you remember, this is the happy face, if you will. So we're going to take that b over 2a, and we're going to square it. And remember that when you have, when you have a single term in the parentheses, this exponent distributes to every factor within that parentheses. B squared is just b squared. 2 squared is 4. And a squared is, well, a squared. And this is that squiggly face that I showed you. Awesome. And remember what we do is we take this squiggly face and add it to both sides of this equation. So that's going to give me x squared plus b over ax plus the squiggly face, which is b squared over 4a squared, and I'm going to add that to both sides. Excellent. This left-hand side is guaranteed to factor the exact same way every time, and it will be x something squared. Now, that something is always what we got when we first divided by 2, which was b over 2a. So we're going to add on that b over 2a here. This right-hand side, though, we need to go ahead and combine this, which means we need a common denominator. So we need 4a squared here and an a here. So the common denominator between these two is 4a squared. So that means that the first fraction needs to be multiplied by 4a on top and bottom. And just because I want to, I'm going to go ahead and write the b squared over 4a squared first here. And then subtract, because this is a negative here, 4ac all over 4a squared there. And notice we have a common denominator, which means that we have x plus b over 2a squared is equal to b squared minus 4ac all over 4a squared. Now again, because we have this in this form, this is actually the place where we use the square root property. So that gives me x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 4a squared. Now if you notice, this square root goes to both the numerator and denominator separately, so you would think of this as x plus b over 2a equals plus or minus the square root of the numerator, b squared minus 4ac, all over the denominator of the square root of 4a squared. But here's the thing, square root of 4 is 2, and the square root of a squared is just a, specifically when a is positive. Excellent. Now, why did I do the square root of the bottom but not the top? Well, the reason I did that is because in the numerator, we have two different terms, but in the denominator, we only have a single term. That means that this will distribute to every factor in the denominator, but in the numerator, it doesn't work. Excellent. Now, let's go ahead and move the b over 2a to the right-hand side, which makes this x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And again, notice that we have a common denominator, which means I can go ahead and combine this into one big expression as negative b plus or minus the square root of b squared minus 4ac all over 2a. Awesome. And that is exactly what we wanted. Wonderful. Now that we have the actual quadratic formula, let's talk about the steps. The steps are the following. The first step is to put it in the general form of ax squared plus bx plus c equals 0 form, specifically where that leading coefficient there is positive. For the second step, find the discriminant, we have b squared minus 4ac. Now, the discriminant is simply what we have underneath the radical, and the reason that we call it the discriminant is because it discriminates between the number and type of solutions. And the reason that that happens is because it is underneath the radical. So if you have the square root of a negative, that gives you an imaginary number. Square root of 0 is 0, and the square root of a positive is a positive real number. So that's actually going to be the differentiation between the number and types of solutions. And once you have that discriminant, you can just plug in the values for b and a and that discriminant. And once you have that, you just completely simplify. And when you did that, you're done. Now, one thing to remind yourself of is the fact that the quadratic formula can be used for every single solitary quadratic equation. But remember that if we specifically ask you to factor, make sure you use the zero factor principle. So it does matter, but it can be used in principle for any equation. Alright, well, I believe I'll go ahead and end it here for this video, and I will see you in the next one. Have fun.